Marie Curie and the discovery of radioactivity. Marie, Marie, it's here, shouted Pierre. Our shipment has arrived. Marie Curie did not even pause to grab her hat. She rushed out into the street after her husband. There it was, a big, heavy wagon like the ones that had brought much-needed coal for their lab's dilapidated stove. But this wagon carried a far more precious and exciting load. A moment later, people passing by the School of Physics and Chemistry were treated to a sight not often seen on the fashionable streets of Paris in the early 1900s. A bareheaded young woman in a laboratory smock ripping eagerly into a pile of heavy sacks and burying her hands in dirt. To the Austrian mine owners who had sent the pitchblende ore, it was just dirt. After all, they had already taken out the valuable part, the metallic element called uranium, and dumped what was left over in a nearby pine forest. If a pair of eccentric French scientists wanted them to scoop up the worthless stuff and ship it, the mine owners were happy to oblige. But Marie and Pierre Curie knew the secret of the dull brown ore. Hidden deep within it was a new chemical element. No one, the Curies included, had ever seen this element. Still, the husband and wife team had given it a name, radium, and Marie was determined to prove radium was real. No one knew how difficult the task would be, but Marie, although still a student, had already shown that she possessed the most important quality of a successful scientist. When it came to the search for knowledge, she never gave up. When she was growing up in Russian-occupied Poland, even to study science was forbidden. Many nights, young Maria Sklodowska, as she was named then, slipped through the dark streets of Warsaw on her way to an illegal night school, glancing anxiously over her shoulder for any sign of the Russian police. Days she worked teaching children, saving her rubles to send her older sister to medical school in the city of intellectual freedom, Paris, France. At last, her own turn came. Her sister, newly married, sent for Marie to join her in Paris. Clutching a blanket and a folding chair, the fourth-class train ticket, all she could afford, did not provide even a seat. She hugged the rest of her family goodbye. When Marie arrived in Paris in 1891, she studied physics at the greatest university in Europe, the Sorbonne. But how poor she was, and how poorly prepared. She barely knew enough French, let alone advanced math and science, to understand the lectures. Marie studied late into the evenings in the library, struggling to catch up with her classmates. Then she climbed the 6 flights to her little room. In the winter it was so cold that she emptied her closet, piling the clothes on her bed so she'd be warm enough to sleep. Sometimes she had no money to buy even an egg or a loaf of bread, but then how could she take the time to stop studying long enough to cook? Her hard work was rewarded. Marie won her degree in physics, graduating first in her class, and the next year she earned a second degree in mathematics. She also met the man who soon became her husband, Pierre Curie, a brilliant young physicist, as promising and as poor as Marie. Their love for each other was equaled only by their shared love of science. It was a thrilling time to be a scientist. The year the Curies were married, 1895, a German physicist named Wilhelm Röntgen discovered a new kind of ray that could be used to see inside people and photograph their bones. He called them X-rays. The X stood for unknown. Not long after, the French physicist Henri Becquerel discovered the uranium let out another type of ray. These rays were weak compared to X-rays, and even Becquerel himself did not think this discovery of much importance. But Marie found the rays fascinating. Where did they come from? How were they produced? She decided to examine these mysterious Becquerel rays for her advanced research. She set to work day after day. Marie experimented with uranium under all kinds of conditions. Dry and wet, powdered and solid, pure and mixed with other elements. She heated the uranium and shone lights on it. Then, using a special instrument called an electrometer, which Pierre and his brother had invented, she measured the uranium rays and carefully copied the numbers down in her notebook. The results were astonishing. It didn't seem to matter what she did to the uranium. Nothing affected the strength of the rays. Nothing but the amount of uranium present. The energy appeared to come from inside the metal itself, deep down at the level of its atoms. Marie named this atomic energy radioactivity. A substance that emitted this energy was called radioactive. Her experiments yielded a second surprise. The sample of uranium-rich pitchblende turned out to be 3 or 4 times as radioactive as pure uranium. How could this be? Marie had already tested every known element in pitchblende. None was radioactive. But something in that pitchblende, something besides the uranium, was sending out rays. There could only be one answer. If the extra radioactivity could not be coming from any known element, it must be coming from an unknown element. Pierre was so excited by Marie's discovery that he dropped his own research on crystals to assist her. They knew the new element, which they decided to call radium, must be extremely tiny to have escaped notice all these years. Maybe it made up as little of the pitchblende as 1%, and yet this tiny bit of radium gave off stronger rays than a much larger amount of uranium. It must be powerfully radioactive. The mine owners had sent them 7 tons of pitchblende. Somewhere in that 7 tons, Pierre and Marie were convinced they would find radium. It was like searching for a needle in a very large haystack, except they had no way of knowing what this needle even looked like, and the needle would turn out to be much smaller than either of them imagined. It was not 1%. It was less than 1/1,000,000th of 1%. No one paid the Curies to do this work. They could not even persuade the School of Physics where Pierre taught to let them use a laboratory. Instead, they were forced to set up shop in an abandoned shed. A visitor once described the Curies' laboratory as a cross between a stable and a potato cellar. In the summer, the heat was stifling. In winter, the old stove barely gave out enough warmth to thaw their frozen hands. The roof leaked when it rained. Yet, Marie would write years later, it was in this miserable old shed that we passed the best and happiest years of our life, devoting our entire days to our work. The work could be backbreaking. Marie spent many hours boiling down pitchblende in enormous pots, stirring the heavy mixture with an iron rod as tall as she was, gasping and coughing from the fumes. Later, she faced the nearly impossible task of producing pure and purer samples in the drafty, dusty shed with its dirt floor. A year, 2 years, 3 years, Marie edged closer to her goal. Sometimes in the evening, she and Pierre put their little daughter to bed, leaving her in the care of her grandfather. Then the couple would walk arm in arm through the Paris streets, returning to their darkened laboratory to gaze at the old wooden tables full of tubes and bottles glowing with a faint blue light. Finally, one day in 1902, they were able to make their announcement to the world. Marie and Pierre Curie had a pure sample of a new element called radium, thousands of times more radioactive than uranium, and it was useful. While Marie had labored to purify radium, Pierre had been experimenting with her samples. He discovered that radium could kill cancer cells. Compared to surgery or to chemicals used to treat cancer at that time, radium was much safer and more effective. Radium rapidly became big business. A single gram was worth $100,000. Manufacturers made their fortunes making and selling radium, using the methods Marie had developed. But Marie and Pierre refused to charge a penny for their discovery. They believed that the true spirit of science meant sharing knowledge freely. The discovery of radioactivity would turn out to be useful in many ways. For example, among other things, doctors now use radioactive dyes to help diagnose medical problems, and scientists can use radioactivity to determine the age of fossils. In 1903, Marie became Dr. Marie Curie. The professors who judged her work, outstanding scientists themselves, told her that no advanced research had ever made such a great contribution to science. Later that same year, she earned a higher honor for her research. Along with Henry Becquerel, the Curies were awarded the Nobel Prize for Physics. Marie Curie became the first woman ever to win a Nobel Prize. She would go on to win a second Nobel Prize in chemistry, making her the first person ever to be awarded the Nobel Prize twice, and the Sorbonne made her its first female professor. But all of these firsts meant little to Marie Curie. For her, what came first was always science.